Is Honors Algebra 2 Pre-Calc. We're doing homework review in Chapter 9 of Pre-Calc, 9.4, number 87 on page 687. So we're asked to find the formula for the sum of the first n terms of the sequence. And then we're given the sequence 9, 13, 17, 21. Now, the intention of the book, given that this is in 9.4, might have been for you to do this by looking for a pattern, which is fine. Nothing wrong with that. So there are two ways to do this. One is to do this by writing the sum of the first term and then the sum of the first two and then the sum of the first three and see if you see a pattern, and that's fine. It happens that this particular sequence is a special kind of sequence, which we talked about in 9.2. This sequence is arithmetic, right? There is a common difference of +4 between each of the subsequent terms, right? So if you recognize that this sequence is arithmetic, then you don't really have to do the look for a pattern thing, right? Because if you know the common difference is 4, right? And you know that the sum of an arithmetic sequence, right, is n over 2, right, half the number of terms, right, because that'd be the number of pairs, and then the first term, which would be a sub 1, plus the nth term, which would be a sub n, then you can actually write, you can essentially write the formula mostly from this information. The other piece of information you would need is that the nth term of an arithmetic sequence is the first term, right, plus n minus 1 times the common difference. Now, knowing those formulae, again, all of these were from 9.2, right, knowing those formulae from 9.2, you could write this formula without using pattern recognition. So let's do that first, and then we'll go through and see if we do it the other way. There might be a really obvious pattern, there might not be. When I saw this, my first thought was, oh, hey, that's arithmetic, so I'm not going to look for a pattern. But we can do it both ways and see how it pans out. So if we do it this way, right, we know my a sub 1 is 9, right? We know my a sub, or we know that my common difference is 4. So my nth term, a sub n, should be 9 plus an n minus 1 times a 4, or if you want to clean that up, you're going to get 4n plus 5, right? And that checks out. If you try plugging in a sub 1, you'd get 4 plus 5, which is 9. If you plug in a sub 2, you'd get 8 plus 5, which is 13. So that checks out. So that's your a sub nth term, right? And then the sum of the first n terms is n over 2, because that's the number of pairs, and then a sub 1, which is 9, plus a sub n. So it seems to me like the formula we're going to get is n over 2 times a 4n plus 14. Or, if you want, you could factor 2 out of that, right? And you could just make this an n times a 2n plus 7. Now, you could check your formula to make sure it works. It's never a bad idea to check that so this is the sum of the first n terms, right? When you make a formula, even if you're using other formulae that you know and are pretty sure are right, it's a good idea to check that you're right just in case. S sub 1, based on my formula, should be 1 times a 2 plus 7, which is a 9, and that's correct. If I only sum the first term, I'd only get a 9. S sub 2 should come out to be a 22, right? Because it should be 9 plus 13. So if I try that, I'd get 2, and then we'd get a 4 plus 7, and sure enough, I get a 22. So far it's panning out. My S sub 3 should be that 22 I already got, and then add another 17, so it should be a 39, and we can check that. S sub 3 would be a 3, and then this would be a 13, and sure enough, 3 times 13 is 39. So that's my formula right here. So again, my S sub n is an n times the quantity 2n plus 7, or you could have used a different version that is simplified more or less. Now, since we already did write the pattern down for the first couple sums, I'm going to point out that we may or may not see an easy pattern here. So let's walk through the other option for how to do this. I want to be 100% clear that the way I just did this problem is absolutely the way I would have done this problem. But if for whatever reason you didn't see that, let's see if there's another logical way to do this using maybe a little bit more of what we saw in 9.4, right? So here's the other logical way I was thinking we could talk about doing this, right? So if we wanted to talk about pattern recognition, we recognize that if we only sum the first term, we get a 9. If we sum the first two terms, we get a 9 plus 13, which is 22. If we sum the first 3 terms, as we already saw, we get a 39, right? And if we sum the first 4 terms, we'd add a 21 to that and get a 60, right? And so we're trying to figure out a formula for S sub n, right? So we could try and analyze this number and see what happens to it and go from there. So let's look at this the sequence of the sums. So let's look at the sum sequence and see if we can analyze that. Again, this is not the way I would do this problem. It doesn't mean that you can't get through it if you do it this way, but I'm just saying it might not be the easiest. So the difference between these two numbers is a 13, and the difference between these two numbers is a 17, which we know because it's these numbers, and the difference between these two is a 21. The constant difference between them is 4s. So remember that if the second difference is constant, right? If our second difference is constant, what that tells us is that so that the nth term, which in this case, this would be S sub n, right? Because it's each one of these was the sums, right? This was S1, S2, S3. That our S sub n is quadratic, right? So that's, sorry, an inch over here, is quadratic, meaning that S sub n should be of the form an squared plus bn plus c. We could then use values that we know, like we know S sub 1, so right, we know that when we plug in a 1, we should get a 9. So if I did S sub 1, I'd get 9 equals A plus B plus C, and if I did S sub 2, I would get 22 equals 4A plus 2B plus C, and if I did S sub 3, I would get a 39 equals a 9A, right, because it's n squared, plus 3b plus c. And then this system is something I could solve either using matrices or using elimination or any number of ways. And I'm going to end up getting the same answer. Just as a quick reminder, the answer we got when I did it the other way that we got pretty darn fast, right, was that S sub n is an n times a 2n plus 7. So if we were looking at that as a distributed quadratic, essentially we would end up getting that a is 2 and b is 7 and c is 0. And that's fine. So you can do that this way and it would work. It's just not the best plan, right? If I were going to do it this way and I didn't have a calculator and thus could not easily use matrices, I would use elimination. So if I had a calculator, if I had already done all this work and I had a calculator, I would make my coefficient matrix of 1, 1, 1, 4, 2, 1, 9, 3, 1, and I would have that times an A, B, C, and that would equal a 9, 22, and a 39. I would call this matrix A, I would call this matrix B. In order to get my A, B, C, I would type into my calculator A inverse times B, and I would absolutely get 2, 7, and 0, which would give me this answer. So that's fine, but if you didn't have a calculator, so let's assume we're in this spot with this system of equations and we don't have a calculator. So I'm going to erase and give myself a lot of space because I've already used up a good amount of space making this happen, but let's go ahead and walk through it. If you not only didn't see the arithmetic sequence thing, but then also did not have access to a calculator and had to solve this by hand, the easiest way to solve it by hand is to take the S2 equation and subtract S1 and take the S3 equation and subtract S1. So if I take S2 minus S1, I'm going to get an equation that looks like this. 22 minus 9, which is a 13, equals 3A plus B, no C. If I do S3 minus S1, I'm going to get 39 minus 9, which is 30, equals 8A plus 2B, no C. I then proceed to do elimination by essentially timesing the entire top equation by a negative 2. If I did that, I would now have the two equations that are negative 26 equals negative 6A minus 2B, 30 equals 8A plus 2B. When I add straight down, I'd get 4 equals 2A. Sure enough, I get A is 2. Once I know A is 2, I back substitute into either equation. I'm going to use the 13. I would back substitute into 13 equals 3 times 2 plus B. There's my 7 equals B. Sorry, that 6 looks a lot like a B. Sorry, it happens. So I get a B for 7, and then in order to find C, I would plug into the easiest of the three equations, which is that 9 equals A plus B plus C, and I would quickly get that C is 0, which again confirms exactly the formula that I got in the much easier way by using an arithmetic sequence. So you're not always going to be handed a problem where something's arithmetic. The other option, if you didn't see any of this, is you could just try and straight up do it using pattern recognition, but that's going to be pretty hard, especially because the answer is 2n squared plus 7n. If the pattern is like n squared plus 1, it's pretty easy to spot, because you're like, oh hey, I see a 5, that's 2 squared plus 1, and I see a 10, oh hey, that's 3 squared plus 1, and hey, I see a 17, and you're going to spot those. But if the pattern is something like 2n squared plus 7n, that's kind of tough to spot unless you use some other techniques.